All right, so let's do a simple exercise to find the instantaneous value of the voltage or current when a sinusoidal form of the signal is available. Okay, so this will help us understand the concept of projection of the signal on y-axis and how that projection helps us find the instantaneous value. Thank you. So let's see the situation. You're given a sinusoidal waveform of an alternating signal, which is this. Okay, and by now you know that this is 90, this is 180, this is 270, and this is 360, and this is 0, this is 90. Now the way to handle this is the alternating current signal in the waveform. Okay, this is the waveform. Also, it's a trigonometric function, which is a sine function. Now, if you want to represent the phasor for this particular signal, one of the easiest way obviously is to write it with the help of the maximum value it has, which is this. So you can say this is V peak, okay, is equal to some value which is maybe 100 volts. And now what you do is you convert this into, okay, so this is the peak value on the other side, this is the peak value on the other side. So okay, these two are equal, and what I do is I draw a circle. Okay, so that's my circle, and this is the peak value, okay, which is this. So this is V peak. So a phasor starts from here and starts revolving with the frequency f, which is of the signal. So if the signal is V is equal to V naught sine omega t, the waveform is getting converted into a phasor. So the phasor also revolves. Okay, it revolves with frequency of the alternating signal. Although the representation is definitely V naught angle 0, but if you have to truly represent this on a piece of paper, this is the correct way of representing the phasor, because it represents the revolving nature of the phasor also. Now assume, let's take up a time period which is t1 here. Okay, so let's say the time period is t1, and now extend this here. So this particular value, the value I'm showing in green now, is the instantaneous value at time t, and can be written as Vt1 is equal to V naught sine of omega t1. And in the phasor diagram, which is also having a circle because the phasor revolves, this particular part, which is a projection of the hypotenuse, which I'm now showing in white, right? This particular part is the instantaneous value, which is also same as this. So this is V instantaneous, and this is also V instantaneous. So in a phasor diagram also, if you show all the phasors with the help of the frequency, you can easily show the instantaneous value. But if you write phasor as the maximum value and the phase angle, you may not be able to show the instantaneous value. But the actual pictorial representation of the phasor is this, and this is a waveform. This is essentially written for the ease, and this is written as part of the vector. Like you have vector algebra, similarly you have phasor algebra. Okay, so this is a phasor algebraic expression But this particular circle that represents the phasor revolving with some frequency omega, and so this is also a phasor, this is also a phasor. The vertical height at all points represents the instantaneous value of the signal, which corresponds to the instantaneous values in the waveform graph. So I hope this clarifies it. This is more of concepts of electrical engineering, but they have been brought in class 12th. And if you understand that a phasor revolves also, it will bring a lot of clarity in your mind. Thank you very much.